Yes, today we'll discuss about change of state.
Ma'am, you said
You
you
all
will
can see
keep
the
the
screen?
video.
Yes, ma'am.
Yes, what you told?
Ma'am, you said you will keep one video today.
Yes, I told I'll show you the video. First we'll discuss this and then I'll show you the video also, okay? Now we'll discuss about the changes of state of matter. When a solid is heated, it changes its state. We all, in our daily life, we all observe this, isn't it, children? Your mother will be preparing, your mother will be boiling the water for the sake of preparing the tea, isn't it? You all have seen it? Yes. So, if you see this, we all, uh, in the summer season, we all need ice cubes. We all see there is a change of state we observe, isn't it? From water, we keep the water in the ice cube and then it converts into a solid ice cubes. This is a change of state here. And even when you boil the water is changing its state from water to vapor. It is evaporating in the form of vapor. So this is the change of state. Changing of state from solid to liquid and from liquid to gaseous state takes place when we heat it or when we cool it. When we cool the water, it changes into solid ice cube. The water changes its state from water to ice cube, from liquid to solid. When a solid is heated, it changes into liquid. When a liquid is heated, it changes into gas. So I hope you all have understood it. Yes. So now can you tell me what is a change of state?
Yes, ma'am.
Yes. Tell me what is a change of state? I want Ritvik Rao to tell me about change of state. How you observe. Can you give me one example of change of state? What you have observed? Ritvik Rao, are you there? Ritvik, speak up. Charan, Charan, can you hear me?
Ma'am.
Can you tell me about what is meant by change of state? Have you seen it anytime?
Yes, ma'am. When we are cooking rice, there will
Yes. When you are,
evaporation will become.
sorry, can you tell me once again? I can't hear you properly.
When we cook a rice, then evaporation will come.
When we
Particles
prepare
will.
rice, you're talking about rice.
Yes, ma'am.
Okay. And when you heat water also, the water evaporates when we heat it. So this is change of state. So how many changes you can see? How many uh, into how many states you can see the changes you can observe? Are they reversible or irreversible? Can you explain me what is a reversible change in this? Yes, Reason.
Ma'am,
Can you explain me the reversible change? Can you tell me what is the reversible change in this? The picture you can see here on the screen. Can you explain it? Is it a reversible change? If it is a reversible change, then how?
Ma'am, can I?
Yes.
can you?
Ma'am, when gas is cooled into liquid,
Yes. One more student.
when gases is changed into liquid, then liquid is cooled to solid, ma'am.
Okay. Yes, Vishnu, can you tell me?
Ma'am, can you?
Yes, Abhinash.
Ma'am. Ma'am, once can you repeat the question, ma'am?
The change of state is reversible or irreversible? If it
Your
is,
voice is breaking, ma'am.
okay.
No, ma'am.
Is this a
No, ma'am.
reversible change? Yes, Abhinash, you can tell the answer if you know.
Yeah, ma'am.
Vishnu, you can tell me.
When water changes to solid, solid to liquid, and liquid to gases, again it will be repeat, ma'am.
It can be reversible.
Yeah, ma'am. It will be repeated.
Evaporation process, ma'am.
Yes.
Yeah.
So these changes are reversible or irreversible?
Reversible.
Ma'am, reversible,
change,
ma'am.
Reversible
Ma'am,
change.
reverse.
They are reversible because we can convert the liquid back into solid again and solid into liquid again. And even into the gaseous form, the gaseous state can be converted into liquid form again when you just cover the lid on the vessel which you're boiling the water. The vapors can convert back into liquid. I'll show you the video for this so that it will be very clear to you. Okay, children? Just inform me if you can't hear it properly.
Which occupies space and has mass is called matter. Matter in our surroundings. Anything which occupies space and has mass is called matter. Air and water, hydrogen and oxygen, sugar and sand, iron and wood, copper and coal, ice and alcohol, milk and oil are all different kinds of matter because all of them occupy space and mass. If we look around us, we can see a large number of things of different shapes, sizes and textures. Many of these things are used by us in our everyday life. For example, we eat food, drink water, breathe in air, and wear clothes. We use table and chair for studying and bed for sleeping. Matter can be classified in a number of ways. Ancient Indian philosophers said that all the matter, living or non-living, was made up of 5 basic elements: air, earth, fire, sky, and water. Matter is made of particles. Everything around us is made of tiny particles. A body is made of particles. A chair is made of particles. The diffusion of potassium permanganate. The number of particles in everything is, however, very, very large. For example, a small raindrop contains about 10 to the power 21 particles of water in it. The particles which make up matter are so small that we cannot see them even with a high-power microscope. Even without seeing them, we have certain evidence which tells us that all the things is made of tiny particles. We will now give some of the evidence which clearly shows that all the matter is made up of tiny particles. This evidence also shows that the particles which make up the matter are constantly moving. Please note that the particles which make up matter are atoms or molecules.
Characteristics of particles of matter. Introduction. Characteristics of particles of matter. The important characteristics of particles of matter are the following. Number 1. The particles of matter are very, very small. Number 2. The particles of matter have spaces between them. Number 3. The particles of matter are constantly moving. And number 4. The particles of matter attract each other. The particles of matter are very, very small. Now, we discuss these properties in detail. So the first property is that the particles of matter are very, very small. The very, very small size of the particles of matter can be shown by performing the following experiment by using potassium permanganate and water. Potassium permanganate is a kind of matter. We take 2 or 3 small crystals of potassium permanganate and dissolve it in 100 milliliters of water in a beaker. We will get a deep purple colored solution of potassium permanganate in water. Take 10 ml of deep purple solution of potassium permanganate from the first beaker and mix it with 90 ml of water present in the second beaker to dilute it. Due to this dilution, the color of potassium in the second beaker become a bit lighter. Now take 10 ml of potassium permanganate solution from the second beaker and mix it with 90 ml of water present in the third beaker to dilute it further. the color of solution will become still lighter. We keep on diluting the permanganate solution like this a number of times. In this way, we get a very dilute solution of potassium permanganate in water, but the water is still colored. This experiment shows that just 2 or 3 tiny crystals of potassium permanganate can impart color to a large volume of water. From this observation, we conclude that each potassium permanganate crystal itself must be made up of millions of small particles which keep on spreading and imparting color to more and more of water. The particles of matter have spaces between them. The spaces between the particles of matter can be shown by performing the following experiment by using water and sugar. We take about 100 ml of water in a beaker. Mark the level of water in the beaker with a marking pen. Also take 50 grams of sugar. Now add 50 grams of sugar in water in the beaker. Dissolve the sugar by stirring it with a glass rod. When all the sugar has dissolved, we get a sugar solution. Let us look at the level of sugar solution in the beaker. We will find that the level of sugar solution in the beaker is at the same mark where water level was initially in the beaker. This means that even after dissolving 50 grams of sugar in 100 ml of water, the volume has not increased. This means that the particles of matter have spaces between them. The particles of matter are constantly moving. The best evidence that particles of matter are constantly moving comes from the studies of diffusion and Brownian motion. A. When we light an incense stick in one corner of a room, its fragrance spreads in the whole room quickly. This observation can be explained as follows. The burning of incense stick produces gases, having pleasant smell. The particles of gases produced by the burning of incense stick move rapidly in all directions, mix with the moving particles of air in the room, and reach every part of the room quickly. So, the observation that the fragrance of a burning incense stick spreads in the entire room very quickly tells us that the particles of matter are constantly moving. The particles of matter attract each other. The next characteristics of matter is that the particles of matter attract each other. There are some forces of attraction between the particles of matter which bind them together. The force of attraction between the particles of the same substance is known as cohesion. The force of attraction is different in the particles of different kinds of matter. If we take a piece of chalk, a cube of ice, and an iron nail and beat them with a hammer, we will find that it is very easy to break the piece of chalk into smaller particles. It requires more force to break a cube of ice, whereas the iron nail does not break at all, even with a large force. This shows that the force of attraction between the particles of chalk is quite weak. The force of attraction between the particles of ice is a bit stronger, whereas the force of attraction between the particles of iron nail is very strong. This is an actual chrome alum crystal. It is a solid. The force of attraction between the particles of chrome alum is large. This is the model of chrome alum crystal showing the arrangement of particles in it. These particles attract one another with a large force. Diffusion. In this section, we will learn about the diffusion in solid, liquid, and gases. Introduction. The spreading out and mixing of a substance with another substance is due to the motion of its particles is called diffusion. The diffusion of one substance into another substance goes on until a uniform mixture is formed. Diffusion is a property of matter which is based on the motion of its particles. Diffusion occurs in gases, liquids, and solids. Diffusion fastest in gases and slowest in solids. The diffusion is fastest in gas because the particles of gases move very rapidly. The diffusion is slowest in solids because the particles in solids do not have much space. The diffusion in liquids is, however, much faster than that in solids. The rate of diffusion increases on increasing the temperature of the diffusing substance. The phenomenon of diffusion tells us that the particles of matter are constantly moving. Diffusion in gases. So now we learn about the diffusion in gases. Diffusion in gases is very fast. This is because the particles in gases move very quickly in all directions. The rate of diffusion of a gas, however, depends on its density. Light gases diffuse faster than heavy gases. The smell of food being cooked in the kitchen reaches us even from a considerable distance. This can be explained as follows. When a food is cooked, some of the substances in food releases gases having the smell of food in them. The particles of these gases move very quickly and mix up with air by diffusion. When the air containing these gases reaches our nose, we get the smell of food being cooked in the kitchen. Thus, the smell of food being cooked reaches us even from a considerable distance by the process of diffusion. See some other examples. When we light an incense stick, in a corner of our room, its fragrance spreads in the whole room very quickly. The fragrance of burning incense stick spreads all around due to the diffusion of its smoke into the air. Diffusion in liquids. Diffusion in liquids is slower than that in gases. This is because the particles in liquids move slowly as compared to the particles in gases. Here are some examples. If a crystal of potassium permanganate is placed at the bottom of water in a beaker,
States of matter.
Just one second. I'll increase it and now you can see it.
Yes, ma'am.
Interconversion of states of matter. Matter around us exists in the solid, liquid, and gaseous state. The state of matter changes from solid to liquid, liquid to gas, or a combination of these. A solid changes its state to liquid by melting. Upon heating solids, the space between the particles increases and the particles move freely to form liquid. When a piece of butter is placed on a frying pan and heated, the piece of butter slowly loses its shape and changes to liquid. Similarly, a liquid changes its state to solid by solidification. Upon freezing liquids, the space between the particles decrease and they solidify. When some water is poured in an ice tray and kept in the freezer, the water solidifies and becomes ice. A liquid changes its state to gaseous form through vaporization. The space between particles increases when heated, thereby forming gas. When water is heated, vapor arises from its surface and so water in a liquid state is converted to a gaseous state. The gas formed can be converted back to liquid. Now, close the beaker with the lid and continue heating. After some time, you will observe droplets of water accumulated on the surface of the lid. Such a process is called condensation. During condensation, vaporized particles are accumulated and form liquid. We have already learned melting, solidification, vaporization, and condensation. Now, can a solid be directly converted to gas and vice versa? When dry ice is kept at -78.5 degrees Celsius at 1 atmospheric pressure, dry ice is converted to gas. This process is called sublimation. And when the gas so formed is trapped, the gas is accumulated to form dry ice again. That shows that a solid can be directly converted to gas and vice versa. As we have earlier seen in vaporization, a liquid is converted to gas before reaching its boiling point. Such a process is relatively known as evaporation. Let's define it. Evaporation is the process by which a liquid changes from its liquid state to gaseous state without being heated to its boiling point. There are many factors which affect the evaporation of liquids. Temperature.
When droplets of water are sprayed into a hot pan, you will observe that the droplets suddenly vaporize and the vapors escape into the atmosphere. This shows that increase of temperature will result in a greater number of water particles being converted to a vapor state. Surface area. When the surface area is increased, the rate of evaporation increases. Here, the glass and the saucer contain water. Both are kept at room temperature. You will observe that after some time, the water level in the saucer has fallen substantially compared to the water level in the glass. The water in the saucer has evaporated due to the increased surface area. Wind speed. These clothes are spread out for drying. As the wind speed increases, the particles of water vapor move away with the wind, decreasing the amount of water vapor in the surrounding. Wind speed increases evaporation. Hence, on a windy day, clothes dry faster. Humidity. Humidity is the amount of water vapor present in air. If the amount of water in the air is high, evaporation will be less. Here, the same volume of water is kept in both beakers. However, they are placed in different weather conditions. Hence, you will observe that under hot conditions, the water level in the beaker drops, whereas in humid conditions, there is no significant change in the water level. This shows that humidity affects evaporation. Evaporation causes cooling. Let us now observe a thermometer where the mercury bulb is secured with a cotton plug. It is dipped in a bottle containing spirit. You will observe that the mercury dips. This indicates that as the spirit evaporates, the temperature reduces and cotton becomes cold. Things to remember. The state of matter changes from solid to liquid, liquid to gas, or a combination of these. Solid changes its state to liquid by melting, and liquid changes its state to solid by solidification. Liquid changes its state to gaseous form through vaporization, and through condensation, gas changes to liquid. Solid can be directly converted to gas through a process of sublimation,
Ma'am,
and
not
gas can
hearing,
be
ma'am,
converted to
video.
solid through deposition.
What happened?
Evaporation.
Not hearing, ma'am, video.
You can't
We
hear
can
me.
hear, ma'am.
Yes,
We
ma'am.
can hear, ma'am.
Okay, you can join again. Those who are getting the problem, you can join again.
Okay, ma'am, I will join again.
Join, then I'll play the video.